here with this power schematic, and I've labeled everything, I've boxed everything up nice and neatly, and this is how it's going to work. I believe I tested the pad actually, and somehow the thing got to 110 degrees, which is absolutely insane. This little tiny little pad got to 110 degrees. Yeah, well, I got the thermal gun, I shot it and everything, and 110, though you could hold it in your hand, so it's either dissipating heat really effectively or poorly, or it had little metallic strands in the pad itself, so unless it was just taking an average, like dissipating evenly, and the thermal gun just like thought, oh yeah, this area is overall, but it was insane. But I think this will work. This will definitely work. We've got our input power here going in, we've got the barrel jack, we've got the solar panel thing going in. I still need to check that. It probably is wrong. I need to put probably some gate resistors, but you know, to limit the inrush of current into the gate and everything. So I'll need to do that. Still need to check. I wrote it down here. No, I didn't. Oh, I wrote it here. Check enable pins. Yep, I need to do that for the most part. So I've got the 24-volt boost converter, which is taking in this. We'll have a max voltage of 12.6 from our 3 series 2 parallel battery pack here. 12.6 will be whatever we're taking. This has a wide range, so it doesn't really matter what's coming in. I just needed the value. I probably should rename this so it's more convenient. Betterly put. Readability, very important when you make schematics. And yet here I am. So, got this going in. We're using this converter here. Took the typical application that would grant me a efficiency, I think it was like 90 odd % or something. So we're going to get 24 volts out. 24 volts out from our varying inputs and whatever, yada yada yada. We've got 2 buck regulators here. Got 3V31. This is for our micro and all peripherals and stuff. Need to check the enable pin to see if it will damage, because I'm planning to send this through a microcontroller and have that controlled. Now I'm still trying to wonder about this cell here. I'm thinking like maybe I should put a relay, or I think it's SCR or something that like is you take a voltage in and then you can pass current through, like a diode, except it has a gate and you can control that gate essentially. Isn't that just a FET then? I don't know. I'll check it. I'll need to check that, because what essentially this will be doing is just conducting, and you'll never use the battery at the end of the day, because this will still remain open, closed. This will allow basically to go through. So moving on to the heat pad regulator. This is the main part of the device. You notice I've used 2 ICs here. This is the main IC, which we will regulate through 1 to 12 volts from our 24-volt input. So we've got our output heat pad VDD. So this, let's start out from here. Input, here got your decoupling pack, caps. Got here your bootstrap capacitor going through here. Got the VCC. I can't remember what this does. I think it was like to tell you if it was working. Oh, we missed the enable pin. We need to do that. And we haven't connected the feedback. Great, let's do that. We need to do the enable pin here. So we need to, obviously we still need to check this. Seems to have missed out quite a lot. So we need to put the ground things, but overall it's coming along quite nicely. Overall, it's coming along really good actually. I'm really proud of this. Okay, so this one links to here. Okay, I need to read back the data sheet. We've got the compensation capacitor resistor here. We've got the switching, so this is our output. Got the inductor because it is a buck converter and whatever. Got our output caps here, and we've got the feedback loop. As you notice, the feedback is coming into here, and you've noticed I don't have a potentiometer or anything, so how am I going to adjust the voltage? This is where this comes in. It's a voltage programmer. Just discovered this recently. Really cool stuff. Program with your micro, control these 4 lines. Try looking for an EPOT, or you know, like, but they're really expensive or they're just going obsolete. The parts I found, obviously I didn't look too hard because I'm a lazy shit, but excuse me. Got the pull-ups here, so these will connect to your micro, and I think it's just a bunch of 1s and 0s set. And you get your determined, or I don't know how it works. I haven't looked into it that much, but when I get to the firmware programming, I'll look into it more. But yes, it looks really cool, really nifty piece. So apparently it injects small current and voltage, and this actually adjusts it from the feedback pin that you're going through here. Actually, this could be wrong. I need to check the schematic for this, because I'm even confusing myself here, but you get the idea. It's basically a voltage programmer controlled by your microcontroller. So now that we've done this, and when we do the checks and whatever, get this all done out the way. I'm going to go ahead to the microcontroller side of things. This is where it's going to get really interesting because the microcontroller I picked is the STM32, but it's got, I think it's STM32WB something something 10cc whatever. Got really interesting. It's a cool little piece of. It's a cool little microcontroller. Honestly, it's got everything that I need for this project. I2C, SPI, things like that. I think it does anyway. It's got Bluetooth and enable. It's Bluetooth enabled. Let's say that. It's got Bluetooth capabilities. That's what I'm looking for. Bluetooth capabilities. So, what does this mean? Because ideally, I would like to create an app of some sort. Of course, it's a bit overkill for an app. Like we could have just used a little pot here, and that would have done the trick. But you know, a little turn thing. But we don't want that. We're lazy beings. We're so lazy. Like we just haven't evolved. Like we want to do things efficiently, and having an app on your phone that you can check. Oh, I'm gonna have the temperature sensor too. That might be cool. Maybe further down, further down the line, have a camera and see how your tempeh is doing or whatever. But that'll be really interesting. See that where that leads. Yeah, so ideally I would like to create an app that you can adjust the temperature manually to set which temperature, and then the regulator will adjust accordingly. So communicating the Bluetooth. I think that'd be a really cool, nifty little thing. You know, it gives us a. I did this project just to get a whole bunch of electronics, you know, do more design. I love what I do. I love electronics so much. So much fun. And I just wanted to learn more, and the best way to learn is through project work. I was always one of those people that like tutorials, you know, I bought so many courses and Udemy because I was stuck in a really shit job. I was stuck, I love my job now, but I was stuck in a really shit job and wasn't really learning what I wanted to learn. So doing course on Udemy, Coursera and whatever, and you know, I was buying books, and books are great. Books are fantastic, but you can't just learn from books alone. You got to like do the actual design. You know, it's like trying to get stronger through reading how to get stronger without doing the actual thing. If that makes sense. So anyway, I still got the books now. Like I'll go through in another video the books I recommend and whatever. Brilliant. But Art Electronics, for example, bought that brilliant book, and you can't just learn. It's just like a huge reference manual almost. It's got so much detail, so crammed into it, but it's been really helpful and everything to like starting off and everything. Really good book, highly recommend. But yeah, the microcontroller side is going to be next, I think, to design. There's all this. I'm really excited for that. And yes, hopefully that all makes sense to you.